just continuing from last lesson, problems involving finding sides. We've already done questions 1, 2 and 3. And we're turning over to question, I believe we've finished off question 4. And now we're going to look at question 5. So first thing you're going to need to do is to draw a diagram. Of length 7.3 metres is attached to the top of a flagpole inclined to the ground at an angle of 62 degrees. Now, we've got a flagpole out the front. You know, we've got a flag flying at the front. I'm going to draw this flagpole so you get an idea. And there's the ground, and then a wire holds that pole down to the ground. So that's the wire. This is the flagpole. There's the flag. We're assuming that the flagpole is at right angles to the ground. Now, you need to mark in the 7.3 metres, and you need to put where the 62 degrees is. And the question says find the height of the flagpole. So does someone want to tell me where to put the 7.3? Do I put it here where my pen is or down the bottom, the 7.3? A wire of length 7.3 is attached to the top of the flagpole. Where's the 7.3 metres? This, good. That's that. That's the wire that holds the flagpole up. And that wire is inclined to the ground. That's the angle. Inclined means angle of inclination, okay? That means the flagpole makes an angle to the ground of 62 degrees. Where do I put the 62? Up there or down here? All right. That's your triangle. So can you see you've got a right angle triangle. You're trying to find H. You don't need to know anything about that because they're saying find the height of the flagpole. We put H. So girls, we've got the 62 and we've got this side and that side. What are those sides in terms of opposite, adjacent or hypotenuse? The H is? Opposite. And this is the hypotenuse. So got it? Sine theta is opposite over hypotenuse. Sine of 62 degrees is H over 7.3. Is the H where you want it to be? It's on top. Is that good? Yes. Good. So you need to move the 7.3 to the other side. So what's the opposite of divide by 7.3? So we go H will be sine of 62 times 7.3. And if anyone's got an answer, that would be great. 6 point now. Can I have exactly what it says? 6 point. Can someone else give it to me? 6 point what? 6.445 meters. Now we're saying to the nearest. Sorry, I'm going to make this bigger. The nearest tenth of a meter. Do you know where the tenths place is? Yeah, that's the units. That's the tenths. First decimal place is the tenths. So we just want it basically to one decimal place, which is 6 point. Okay, that's question 5. Question 6. The rhombus ABCD. Tell me about a rhombus. Tell me about its sides. Yeah, and something even better. Rhombus has how many equal sides? 4. So rhombus ABCD has perimeter of 52. Now, perimeter of 52, what information about the side lengths can I get from that? Rhombus has 4 sides the same. The perimeter is 52. Can you tell me what the side length of this rhombus is? Yeah, it's 52 divided by 4, which is 13 centimetres. So each side of the rhombus is 13 centimetres. Okay, so we've got each of those sides is 13. I'm going to put some of those in, or all of them. It then says the diagonals AC and BD, AC and BD, they intersect at point P. But tell me something else about the diagonals of a rhombus. Bisect at what angle? So that's a right angle. So I'm going to write down here that the diagonals of a rhombus bisect each other, or just bisect, at right angles. Now, unless you can know that, girls, we can't do the question without that. The other thing is we're going to be using trigonometry, which requires right angle triangles as well. So you can't do this question unless you've got a right angle triangle if you want to use trigonometry. And it also says that angle ABC, which is this whole thing, that whole thing ABC is 46. Now I'll put that in another colour. And the pen doesn't work very well. ABC is 46. So that angle in there is 46. Part A. Why does angle ABP equal 23? If the whole thing's 46, tell me about the diagonals of a rhombus. They bisect each other at right angles, but the diagonals of a rhombus, they do something to the angles in the corner. What this one there, girls, equals that. The diagonals of a rhombus is almost the perfect shape. What is the perfect shape? Square. Good. Rhombus is just a tilted square. So the rhombus is basically almost symmetrical no matter how you look at it. That angle equals that one. See the two dots? They're equal. Now these aren't dots because they're not equal to those, but if I put cross and cross, they're equal. The diagonals of a rhombus bisect the what? What are these called? What are those corners called? The vertices or the angles of the rhombus. So the diagonals of a rhombus bisect the vertices, or you can put, or the angles of the rhombus. Now, unless you know that those properties of the rhombus, you can't do this question. Diagonals of a rhombus bisect each other at right angles. Diagonals of a rhombus bisect the vertices or the angles of the rhombus. So I'm putting all these. So that means that angle ABP would be a half of angle ABC. See, ABP is a half of ABC, which is a half of 46, which is 23. That is why angle ABP is 23. All right, I'll make it a little bit smaller. Then you have to find the length of diagonal AC. Just make sure you're drawing. All right, you've got to be careful here. You can't do it in one step. You can only work in one of the right angle triangles. So which one should I? You just found the size of angle ABP, so in there's 23. So I'm going to draw that triangle there. A, P, B, and this is 23. What else do I know? 90, yep. What length is AB? 13. So girls, I'm drawing that top triangle up there with 23. Do you get what I'm doing? Now, which side should I find if I want to find AC? What should I find? Should I find BP or AP? I want to find AC. I should find AP, and then what am I going to do with it? Double it. Because AP equals PC, because diagonals of a rhombus bisect, cut each other in half. Okay, so we're going to work out AP, so I'm going to call that X. So let's work out AP. So we're going to work out AP. All right, sine, cos, or tan. Label the sides. There's your 23. What are you going to do? Hello? Well, adjacent's there. Opposite over hypotenuse. So we've got sine theta is opposite over hypotenuse. Sine of, anyone? 23 equals x over 13. X is on the numerator, great, all good. To get x on its own, at the moment it's x divide by 13. Opposite of divide by 13 is 2 times. So therefore x is sine 23 times 13. Anyone got an answer? Do not round it off. 5.079. Dot, dot, dot. So you write 5.079 dot, dot, dot. Then you go, therefore, coming back up here, therefore AC equals 2 times AP, which is 2 times 5.079 dot, dot, dot. You won't have cleared that from the calculator. And what do you get? 10 point what? 10.1. 159 ... We need it to the nearest millimetre. Now, girls, this is in centimetres. You don't need the diagram? This is in centimetres. Do you remember what I said? How many millimetres in a centimetre? 10. So how many decimal places do you give me?
1.
Yeah, that's the centimetre place. That will be 1/10 of a centimetre is a millimetre. You give it me to 1 decimal place, that will be 10.2. So therefore, the length of the diagonal AC is 10.2 centimetres. Now I'm going to stop this video.